The Florida Healthcare Engineering Association, FHEA, is pleased to present this issue of Science Screen Report. We hope it may widen your horizons about the role science and technology plays in today's world and stimulate an interest in pursuing scientific careers. The FHEA comprises a group of professionals who are responsible for all aspects of the physical environment of Florida's hospitals and healthcare facilities. Hospital and healthcare facilities management offers an exciting, challenging, and rewarding career. For more information about the FHEA, please visit our website at www.fhea.org. People have been aware of elements since ancient times. With improved understanding of elements, scientists began to experiment with ways to organize them, searching for patterns to make better sense of their characteristics and to help predict the properties of elements yet to be discovered. Dmitri Mendeleev was the first to organize a table similar to the one we use today. When elements were ordered by increasing atomic weight, a pattern showed where properties of the elements repeated regularly or periodically. The periodic table is a masterpiece of a simple systematic tool of organized chemical information. The evolution of chemistry's periodic table into the current form is an astonishing achievement, with major contributions from many famous chemists and other eminent scientists. The periodic table allows for easy understanding and recalling the properties of the many elements and is the cornerstone of fundamental scientific knowledge. Elements are classified according to their properties. The major categories of elements are the metals, nonmetals, and metalloids. Furthermore, there are rows or periods that extend horizontally, illustrating recurring trends in the chemical behavior of the elements as their atomic number increases. There is also importance on the element's vertical placement. Groups or columns are explained under modern quantum mechanical theories of atomic structure as containing elements that have the same electron configurations in their valence shell or outer energy level. The groups are numbered numerically from 1 to 18, beginning with the leftmost column, the alkali metals, to the rightmost column, the noble gases. Lithium with atomic number 3 is in the first group, the alkali metals. There are several exceptions regarding the periodic table, and one is that hydrogen is in the first column, but it is not considered to be an alkali metal. The rest of Group 1 consists of lithium, Li, sodium, Na, potassium, K, rubidium, Rb, cesium, Cs, and francium, Fr. The alkali metals share many similar properties. They are all shiny, soft, highly reactive metals at standard pressure and temperature. As with all metals, the alkali metals are malleable, ductile, and often softer than other metals. They all have one electron in the outermost orbital. The alkali metals are also known as alkaline metals, but there is a separate group called alkaline earth metals that is very different. The alkali metals are highly reactive metals that do not occur freely in nature. They are highly reactive because they only contain one electron in their outer shell and are ready to lose that one electron in ionic bonding with other elements. Alkali metals can explode if they are exposed to water. They are good conductors of heat and electricity. Cesium and francium are the most reactive elements in this group. Francium is very rare due to its extremely high radioactivity and thus occurs only in traces due to its presence in natural decay chains. Lithium is a rare element with atomic number 3, found primarily in very small amounts in molten rock and saltwater. It is non-vital in human biological processes, although it is used in a multitude of drug treatments because of its positive effects on the human brain. Due to its reactive properties, it is utilized in batteries. nuclear fusion reactions, and thermonuclear weapons. Lithium is most commonly found combined with aluminum, silicon, and oxygen to form minerals. Although these minerals can be found on each of the 6 inhabited continents, lithium is primarily mined in Australia, China, Bolivia, and Chile. Mining for lithium is becoming less essential because newer methods have been developed to make use of the lithium salts found in saltwater. Of all the Group 1 metals, lithium is the least reactive. It takes more energy to remove lithium's 1 valence electron than it does with other Group 1 elements because lithium's electron is closer to its nucleus. Lithium has a high electrochemical potential, so it is useful as the anode in batteries. An anode is an electrode through which positive electric charge flows into a polarized electrical device. In rechargeable batteries, such as for cell phones and laptops, lithium ions move from the negative to positive electrode when discharging, and vice versa when charging. Lithium is the lightest known metal and can be alloyed with aluminum, copper, manganese, and cadmium to make strong, lightweight metals for aircraft. What is the difference between alkali metals and alkali earth metals? Right next door to the alkali metals is the second most reactive family of elements on the periodic table, the alkali earth metals in Group 2. The alkali earth metals include beryllium, Be, magnesium, Mg, calcium, Ca, strontium, Sr, barium, Ba, and radium, Ra. These elements are referred to as alkaline because when mixed with solutions, they are likely to result in a pH greater than 7. Beryllium is a lightweight steel gray colored element with atomic number 4 and is the first of the alkali earth metals in Group 2. Beryllium can be produced in cosmic rays but is short-lived. It is also relatively rare on Earth. Countries such as the United States, China, and Kazakhstan are the top producers in industrial-scale extractions of beryllium. The extraction of beryllium from its compounds is a difficult process. It is a divalent element which occurs naturally only in combination with other elements in minerals. It is found in beryl gemstones such as morganite, aquamarine, and emerald. Beryllium has 12 known isotopes, but only one of them, beryllium-9, is stable enough to occur naturally. Beryllium combines with many nonmetals to form binary compounds, such as beryllium oxide, a white solid that has a high melting point, making it useful in engines, spacecraft, radio equipment, and semiconductors. In the healthcare industry, beryllium is used because of its very low absorption of X-rays and is therefore implemented in radiation windows for X-ray tubes and MRI machines. Because it only has 4 protons, beryllium is relatively transparent to energetic particles. Therefore, it is used to build the beam pipe around the collision region in particle physics setups, such as all 4 main detector experiments at the Large Hadron Collider. The low density of beryllium allows collision products to reach the surrounding detectors without interruption. Its stiffness allows a powerful vacuum to be produced within the pipe to minimize interaction with gases, and its thermal stability allows it to function correctly at temperatures of only a few degrees above absolute zero. Its properties also keep it from interfering with the magnet systems used to steer and focus the particle beams in the Large Hadron Collider. However, scientists are researching potential substitutes as beryllium is expensive to produce and has safety restrictions because of its toxicity. Careers in these fields are rewarding and exciting due to rapid advances and the demand for better products. Scientists and engineers are constantly striving for better, longer-lasting batteries or more stable materials to use in space. Students interested in careers in these fields should focus on chemistry and engineering. The knowledge of elemental properties and behaviors has helped scientists and engineers decipher the best uses for elements in countless applications. For an excellent interactive version of the periodic table of the elements, please visit www.ptable.com or use the link provided on this DVD. Sometimes simple daily chores such as making breakfast, doing the laundry, or driving a car are taken for granted. The simple act of writing a letter or the more complex task such as playing the guitar both require a special combination of movements from the muscular and skeletal systems with commands from the nervous system. And if you consider walking, running, or riding a bike, the strength and dexterity of your legs is integral. In the event that a person loses a limb to disease or injury, or if they were born without one, orthotics and prosthetics can be invaluable. The loss of a hand or an arm can severely hamper job requirements or activities required in daily life. The loss of a foot or leg has obvious implications regarding walking and running. Designing and creating prosthetic devices is a highly personalized science because it can change a person's life for the better.
The Hanger vision has always been to consider the total patient, not just the part that's lost.
Hanger Incorporated is the leading provider of prosthetics and orthotics in the United States. In 1861, just before the first land battle of the American Civil War, a young James Edward Hanger suffered a devastating injury that required leg amputation. As an aspiring engineer, Hanger set out to find a solution, and the Hanger Company was formed. Currently employing over 5,000 people, Hanger successfully helps people with physical challenges lead productive, independent lives. Hanger Clinic partners with prosthetic and orthotic manufacturers to design and test the most advanced technologies in the world, including the Michelangelo hand, the B-Bionic hand, the iLimb hand, and the Elan microprocessor-controlled hydraulic foot.
In my opinion, the biggest prosthetic breakthroughs in the past 20 years have got to be microprocessor technologies, utilizing computers in knees and ankles and upper extremities where you have them in the hands, the fingertips. It's awesome to see where prosthetics have come. Also how the prosthetic system is attached to the person's body, where we utilize gel materials, where the prosthetic system is more comfortable than ever. So we now have people walking, running, jumping and doing all sorts of things with prosthetics. So the future is very, very bright.
The B-Bionic hand is a new generation fully articulating myoelectric hand, combining innovative technology with a lifelike appearance. The B-Bionic hand utilizes motors in the palm that reduces the relative weight of the device. Each finger features a spring return, allowing the fingers to naturally flex when loaded, useful when pushing down on the hand to aid standing up from a chair. Individual actuators drive each finger, allowing each digit to move and grip in a natural and coordinated manner, providing compliant and conformable grips around complex shapes. The Elan is a hydraulic foot controlled by microprocessors to provide real-time simultaneous adjustments while walking. It is designed to adapt dynamically when the user is walking on a variety of surfaces and changing gait speeds. The Elan provides a brake effect when walking down inclines, resulting in optimized momentum and security. This gives the user the ability to negotiate uneven terrain, such as slopes and ramps, all with less effort, increased stability, and greater confidence. With sensors that determine the direction and speed of the foot's movement, the microprocessor controls the flexion angle of the ankle, allowing the foot to lift during the swing phase and adjust to changes in force, speed, and terrain during the step phase.
I'm Chad Viduri. I'm from Jarrell, Texas. I am below the knee amputee. I lost my leg about 5 years ago in a forklift accident. Ended up amputating the leg. Tried to find a foot that actually worked for me. Usually with the non-articulating foot, it was a little more difficult to walk up and down hills. Sometimes I would have to walk sideways, step by step. Falling, tripping on things was quite a bit of an issue for me. With the Elan, I just walk normal. It pushes me along. It helps me slow down when I need to slow down, come to a complete stop. Being on my feet all day long, every day, it really helps me out. Even when I'm walking through a parking lot or on a trail, when I step on a rock or stick, I don't feel the adjustments. It just accommodates for it and it feels very normal.
Looks good.
Having a microprocessor foot is just like having a cell phone. You pretty much plug it in every night and to charge it. The charge lasts me all day long no matter what I do.
All the programming that's required for the foot happens in the office. And then once they leave the office and the foot's programmed, they essentially don't have anything to do besides charge the foot. It's the best compliment to see a patient walking, let's say in pants, and you can't even tell they're an amputee. And the patients that I've seen that have been in an Elan foot, that is how they ambulate.
The single greatest breakthrough, now that's a difficult question, that's very exciting as well, will probably relate to the device itself, osseointegration, where the device is actually affixed to the bone. It is going to communicate with the patient more like the actual limb that the patient has lost.
You're going to see a combination of techniques and new techniques developed that will incorporate every aspect of the body. The neurological system, the vascular supply, the skeletal structure, the tissue density, the skin integrity, everything. And then you'll map that against a simulator, which that simulator will then predict how well somebody's going to do in a prosthesis or orthotic device.
I believe a limb of the future will be biologically connected to the patient, taking like a titanium leg or a bone and attaching it to an existing bone. And I believe we will find ways to tap into those biological systems.
The single greatest breakthrough is really going to be around a neural interface and how those devices interact directly with the brain function.
We're really going to be looking at the perfect orthosis, which is invisible. As a result of the internal implants, we'll be able to reprogram that muscle activity to enhance their walking abilities or whatever movement patterns we're looking for.
Although prosthetic devices are not quite capable of the same tasks as a patient's original biological limbs, scientists and engineers are striving to mimic the anatomy and physiology of missing limbs to give patients a realistic experience. The closer they can get to the real thing, the better, because people often struggle with emotional aspects of losing a limb, as well as the physical absence.
We are going to see much more integration between the practitioner, the patient, and digital technology.
The reality is most patients won't have to come into a physical office. A lot of things should be able to be handled through a virtual environment, through automatic software updates, through wireless networks.
Some prosthetic devices are simple and minimally functional, while others are complex bionic artificial limbs. Improved designs have advanced hydraulics, lightweight materials such as carbon fiber, and computer microprocessors and sensors. Myoelectric limbs are rapidly improving, with the ability to convert muscle movements to electrical signals. Myoelectric sensor systems require a number of electrodes implanted in the person's body. The electrodes connect the brain to the prosthetic device, where electric signals are converted into a digital format for the prosthetic device's robotic motors. Scientists seek to discover the right combination of optical nerve stimulation and nerve sensing technology to create a two-way interface that lets the brain command the prosthetic device while feeling sensations such as temperature or pressure. The future is exciting in the world of prosthetics, as scientists' designs will one day interface seamlessly with the brain like real limbs. Designing and building prosthetics is a career that requires creativity, ingenuity, and innovation. However, industry specialists estimate prosthetic specialists are in decline, and that by the year 2020, there will be a 47% increase in the amputee population. If the shortage of prosthetists continues, only 68% of those in need of prosthetic care will have access to trained help. The American Academy of Orthotists and Prosthetists is hoping to get more young people interested in careers in prosthetics through a series of outreach efforts designed to increase high school students' awareness and interest in the profession. It is called Project Quantum Leap. In addition to disseminating information through high school guidance counselors and job fairs, the key feature of the awareness campaign is a one-stop website, www.opcareers.org. Scientists and engineers continue to make incredible strides with prosthetics, And with advances in robotic devices and sensors and electrodes able to receive messages from the brain, people who have lost limbs will see improvements in their lifestyles for years to come. Radio astronomy has altered the way we view the universe and dramatically increased our knowledge of it. Our passion for learning about what lies beyond the stars has driven scientists and engineers to build extraordinary devices for looking into distant galaxies. The National Radio Astronomy Observatory began building the Very Large Array, or the VLA telescope, in the 1970s. The VLA is a multi-purpose instrument, an array of 27 antennas that help scientists investigate a variety of astronomical objects, including radio galaxies, quasars, pulsars, remnants of supernova, gamma-ray bursts, radio-emitting stars, the sun and planets, astrophysical masers, black holes, and the hydrogen gas that constitutes a large portion of the Milky Way galaxy. On the plains of San Agustin in central New Mexico, the Carl J. Jansky Very Large Array is the world's premier radio telescope observatory. In 2011, a decade-long upgrade project resulted in the VLA expanding its technical capabilities by replacing old electronics with newer state-of-the-art equipment. The scientific community and the public were asked to suggest a new name, and in 2013 it was renamed the Carl G. Jansky Very Large Array to honor the scientist credited with the discovery of radio waves from the Milky Way. The VLA certainly lives up to its name. Each antenna is 94 feet tall, and the dishes are 82 feet in diameter. They're spread out in a Y form 13 miles in different directions. Combined, they make a massive synchronized system that monitors a unique kind of light. Multiple linked telescopes used in an array is referred to as aperture synthesis. Our eyes see only a small sliver of the light that reaches us from space because objects in space emit light across the entire electromagnetic spectrum. At the long wavelength end of the spectrum is radio light. Because its wavelengths are so long, making sharp pictures from radio light requires a telescope that is miles wide. This invisible light reveals the birth of stars, the secret of ancient galaxies, and the presence of black holes. Before the 1930s, optical telescopes were the only tools astronomers had. In 1932, Carl Jansky made the pivotal discovery of radio waves coming from the Milky Way galaxy. The ability to record and study radio waves has allowed for substantive increases in astronomical knowledge. Since its completion in 1980, the VLA has been making astounding discoveries, from water ice on Mercury to the remarkable jets of elliptical galaxies, and the physics behind gamma-ray bursts, the most powerful explosions in the known universe. 50 miles east of the array is the town of Socorro, where the VLA's scientific center is located. This is where astronomers take the information from the VLA and study the latest chapters in the story of the cosmos.
As an astronomer, I spend a lot of my time sitting at my desk in front of a computer. And while we get observations from telescopes like the VLA, most of the time is spent reducing that data, analyzing that data, and trying to figure out what's going on.
Many astronomers find objects that can become a career-long focus.
Henize 210 is visible in the south, and it's in the constellation Pyxis, and it's about 30 million light years away. It's a very small little galaxy, but it's a hotspot for star formation. There are these young, massive star clusters forming today, and these are similar to the types of clusters that were formed back in the early universe.
The dwarf galaxy Hanais 210 is 10 times farther away than the most distant object we can see with the naked eye. Its secrets are hidden behind gas and dust, but radio waves have been escaping and can be captured by the VLA. On Earth, these extremely weak radio waves must be distinguished apart from thousands of other man-made radio interference. In a custom-built test chamber, VLA engineers measure radio signals given off by everyday items, such as this cell phone.
Get it here, test it, get ready to test it. Check what we're seeing on the spectrum analyzer screen. Oh yes. So you can see we're getting some really strong RFI here in the 2.4 to 2.5 gigahertz range.
Even with no service, the radio emission is some 20 trillion times stronger than the most powerful radio sources in deep space. Back at the telescope location, there are engineers that tackle general maintenance routines. Every few months, they climb 30 feet to the apex for critical installation and maintenance of the P-band receivers. These low-band receivers are especially important for detecting invisible hydrogen gas in the early universe, the main ingredient of future stars and galaxies. Regular upgrades like these are important to keep the telescope running with the newest technology. The entire array has recently gone through major upgrades. The original array, completed in 1980, was rebuilt from the inside out. In 10 years' time, nearly all of the electronics inside the telescope were replaced, essentially creating new instruments with old skeletons. At the center of the VLA expansion project was the development of a new supercomputer called the Correlator. It is housed in a meticulously controlled cleanroom environment. This powerful computer turns 27 radio dishes into one enormous telescope. Massive data streams from each antenna are fed to the control building, where the correlator increases the telescope's capabilities by more than 2,000 times. Not only do the dishes adjust and move to track objects in the sky, they also move throughout the array itself. Custom-built 90-ton flatbed locomotives are used as antenna transporters. Engineers carefully line up the locomotives under the telescope's triangular base. Once they're secured, 230 tons of steel is hoisted into the air, and the antenna is slowly transported to its destination. They will not move an antenna if winds exceed 20 miles per hour. And maximum transport speed of the locomotives is 5 miles per hour. The upgraded antenna is carefully mounted and secured in its new home in the vast array. But the placement isn't permanent. Approximately every 4 months, the antennas are moved into one of 4 different configurations, A through D. Each configuration changes the depth and detail the telescope sees. Combining data from each of the 4 different configurations deliver the best image quality. When the antennas are packed together into the D configuration, the telescope detects faintly glowing clouds of gas. At their furthest distance from each other, in the A configuration, they capture the finest details of the radio universe. With several more adjustments, astronomers are ready to study the light of the dwarf galaxy Panais 210.
Copy that. We're getting ready to run the C-band observation.
This light from Panais 210 has traveled through gas and dust for 30 million years and 150 quintillion miles to reach us. An entirely new catalog of human knowledge is captured and recorded.
Our team just finished reducing all of our new data, and we have some spectacular images now. And we can do a very detailed comparison between the optical data from the Hubble Space Telescope, the infrared data from the Hubble Space Telescope, and now the radio data from the VLA. We found this source of radio emission that looked very much like it might be a supermassive black hole in this tiny little galaxy.
Deep in this galaxy, 30 times smaller than our Milky Way, this supermassive black hole is feeding on the surrounding gas.
This has implications for our understanding of the evolution of galaxies and their black holes, and even the formation of the first black holes back in the early universe.
Careers in astronomy can be extremely challenging, but highly rewarding. Students interested can research through NASA, the NRAO, or the National Optical Astronomy Observatory. A keen focus on physics, math, and astronomy courses is the best place to start. The ability to detect and understand radio frequencies has given astronomers the chance to gather information about some of the most important discoveries related to the birth of stars and galaxies. As this technology advances, we can expect the future to be filled with exciting new discoveries about the building blocks of far-off galaxies. The geology of South Florida and a warm, wet subtropical climate provide conditions well suited for a large marshland ecosystem known as the Everglades. The Everglades is a part of a series of interdependent ecosystems that include cypress swamps, mangrove forests, tropical hardwood hammocks, pine rockland, and the marine environment of Florida Bay. However, over the past 100 years, careless development and draining of this unique ecosystem has compromised its health. A massive restoration plan has been implemented that may require 40 years and approximately $10 billion to complete. Teams of biologists started at the Kissimmee River in central Florida near Orlando to follow up on the immense restoration and environmental cleanup that has helped to improve the areas. The Everglades begin at the Kissimmee River near Orlando, Florida. This river flows south to Lake Okeechobee. As water leaves Lake Okeechobee, it flows further south across a limestone shelf and empties into the Florida Bay at the southern end of the state near the Florida Keys. The Everglades began to form about 5,000 years ago when sea levels had stabilized after the last ice age. Mangrove coastlines, hardwood forests, and cypress swamps began to flourish. Water covered the lower half of the state and slowly drained into estuaries, supporting a dynamic saltwater system. As the United States was colonized and developed, industrialized settlers were drawn to the area. and the Everglades were transformed as the demand for farmland, timber, and land for development grew. Drainage canals were built, exposing millions of acres previously covered by water. Devastating hurricanes brought the demand for flood control systems, and the growing population needed a dependable supply of water. Within 50 years, over half of the Everglades were transformed dramatically. In the late 1800s, a developer by the name of Hamilton Diston had good intentions of rerouting the headwaters of the Kissimmee River. He imagined it would create thousands of acres of new fertile land that he could sell. It is now considered one of the biggest environmental mistakes ever made.
The liquid heart of this area is Lake Okeechobee, the big water. This monster had to be controlled by bigger levees and by bigger canals that would give it bigger outlets to the sea.
The original Kissimmee River had meandered over 100 miles from Lake Kissimmee to Lake Okeechobee. And when it rained, the river swelled out into a floodplain nearly 2 miles wide. During the winter or drier seasons, the river would shrink back to the smaller, slow twisting course. This cycle was critical to the many species in the area. In the 1940s, the state of Florida requested federal assistance because major hurricanes had created intense flooding. The Army Corps of Engineers responded by rechanneling the Kissimmee River. The old meandering twists and turns of the river disappeared, along with the floodplains. The most distressing result of this was that the natural filters that protected the river from phosphorus and other agricultural and urban runoff were no longer filtering the water flow. Subsequently, the newly dredged canal became a direct pipeline for contaminated water to flow into the heart of the Everglades. In the 1990s, scientists and engineers came up with a plan to backfill parts of the man-made canal and reconnect the original winding river. They hoped that the old river still had the ability to heal itself. Further phases of restoration are currently ongoing, and the results have been favorable. Since the completion of Phase 1 of restoration, scientists have discovered promising increases in dissolved oxygen levels, which is essential for aquatic life. Reductions in floating plant cover and accumulated sediments on the river bottom, recovery of wetlands, and increased populations of waterfowl, wading birds, and several fish species. By slowing down the flow, water gets stored in the floodplains, allowing for longer dwell time for cleansing and filtering out chemicals such as phosphorus. The Kissimmee River ends at Lake Okeechobee, the 4th largest lake in America, and sometimes when too much pollution is present, this immense body of water can suffer greatly. High levels of phosphorus from agriculture and lawn fertilizers can fuel explosive plant growth and algae blooms. These blooms use up large quantities of oxygen in the water as decomposers break down dead plant life. Algal blooms also block sunlight from reaching underwater plants and fish. Storm water slowly seeps into Lake Okeechobee from many sources. The pollutants settle on the lake bottom, mixing in with the sediment. When tropical storms or hurricanes pass over or near the lake, the sediment is churned up and resuspended in the water. Previously, when the lake's water levels rose, control systems were used to prevent flooding. They released water east and west, and concentrated pollutants began to flow into these areas. The new restoration project returns the overflow to its natural course, to the south. In the past, as the area south of Lake Okeechobee was drained, the land became a very productive environment for farmers because of the subtropical climate and the rich deposits of peat soil, which was created by seasonal floods over thousands of years. The peat soil is commonly referred to as muck or black gold. Farmers face many difficulties, especially biomechanical oxidation. Tiny microbes break down the carbon in the soil, releasing carbon dioxide into the environment. The soil is susceptible to burning, and being so light, it can blow away in the wind. Scientists continually check the soil quality, water quantity and quality, water distribution, bottom sediments, and phosphorus levels. The thick growth of native cattails can become a nuisance. High phosphorus caused the cattails to thrive, blocking other native plants and keeping certain waterfowl away. Scientists continue south, taking core samples containing bottom sediments. They find a noticeable white layer from the sample. Further south still, they find that the phosphorus levels have dropped and the white layer seems to have disappeared, proving that phosphorus is being filtered out along the way. This may appear like pond scum, but it's perfectly natural. This is called calcareous periphyton, communities of algae, fungus, and bacteria that grow as a thin film on rocks and plants and sometimes just float along on the surface. It's important to the Everglades because it is food for other animals, creates oxygen for the water, and filters out phosphorus. Biologists are also incorporating larger-scale projects to help cleanse the waters and reconstruct wetlands by maintaining a specially engineered mix of plants. They match plant species ideal for metabolizing or filtering out the specific level of nutrients present in the water.
In reality, for us to get somewhat back to where we were, we have to combine a mechanical process along with a natural biological process, right?
Yeah, and that's a real challenge.
Water leaving the Everglades agricultural area passes through a pump station into a series of treatment cells that are filled with vegetation that can reduce phosphorus. Nutrient-rich water first passes through emergent vegetation, such as cattails. These plants take turns further cleansing the water, dropping the phosphorus levels by about 80%. From there, clean water heads south, entering the natural wetlands of the Everglades. These treatment areas have prevented well over 2,200 metric tons of phosphorus from entering the Everglades in the past 10 years. Biologists also closely monitor tree islands in the marshes. Tree islands are small teardrop strips in the marshes that rise up above the water levels and offer the only real dry land areas for varied species of birds, mammals, and plants.
And even though you can see on this image that the green might only represent 10% of the total Everglades, it represents more than 50% of the biodiversity of the Everglades.
Seasonal fluctuations in water levels are important to many species, especially thousands of wading birds that migrate here every year.
If that nest and the surrounding habitat also gets too deep, then the parents can no longer forage because their beaks are only 6 inches or their legs are only a foot. If the water depth goes over a foot, it's too deep to feed the young and the young perish.
This is the Fakahatchee strand of the Everglades on the southwest coast of Florida.
So Mike, why do you call this the Amazon of Florida?
Well, because of all the water here in these sloughs in the Fakahatchee strand, it tends to moderate the temperature and the humidity. And all that humidity saturates the air and elevates the dew point above freezing, so it keeps it frost-free. So it's like the tropics.
Frost-free.
Many people think the Everglades ecosystems end on land. But the reality is that the flow of water extends far out into Florida Bay, the Gulf of Mexico, and the Atlantic Ocean. Where runoff containing chemicals makes it to the ocean just off the Florida coast, scientists witnessed a system in decline. coral polyps are negatively affected by algae, bleaching, or diseases such as red band or black band from poor water quality. There are all types of scientists involved in protecting the health of ecosystems like the Everglades. Biologists study the many life forms. Botanists determine how plant life is necessary for the environment. Chemists test chemicals in the water. And ornithologists keep a close eye on bird life. Organizations such as the U.S. Fish and Wildlife Service, the Florida Fish and Wildlife Conservation Commission, and the U.S. Department of Agriculture, along with many others, have banded together to help protect the Everglades. Even scientists must evolve with this sensitive habitat as they learn new ways to battle the problems that come along with an increasing population, invasive species, and the influx of chemicals into the Everglades. We must be careful, treating the environment with the utmost care and concern, as the health of these delicate ecosystems also affects our health. Water is often perceived to be ordinary, as it is transparent, odorless, tasteless, and abundant in many places. It is the simplest compound of the two most common reactive elements, consisting of just two hydrogen atoms attached to a single oxygen atom. Very few molecules are smaller or lighter. Liquid water, however, is a most extraordinary substance. Water is essential for life. Earth's inhabitants cannot live without it. It is equally important to the environment and the water cycle that drives the intricate balance. Over 70% of the Earth is covered with water, 326 million trillion gallons. The oceans hold most of the Earth's water, but water is also present in the polar ice caps and glaciers, aquifers and wells, and lakes and rivers. Only 3% of the world's water supply is freshwater, and 77% of that is frozen. The Earth's water is always in motion and commonly changes states between solid, liquid, and gas. Some water floats in the air as clouds and water vapor. The natural water cycle, also called the hydrologic cycle, is the continuous movement of water on, above, and below the Earth's surface. This cycle is powered by solar energy. The water cycle involves water evaporating or turning into a gas, rising up into the atmosphere, cooling and condensing into drops of water or ice crystals that we see as clouds, and falling back to Earth as rain, snow, or hail, before evaporating again and continuing the cycle. Water moves from one reservoir to another by the physical processes of evaporation, condensation, precipitation, infiltration, runoff, and subsurface flow. The water cycle involves the exchange of energy, which leads to temperature changes. Water is a molecule with one oxygen atom and two hydrogen atoms, bonded together by shared electrons. It is a V-shaped polar molecule, meaning it is positively charged near the hydrogen atoms and negatively charged near the oxygen atom. This polarity makes water molecules naturally attracted to each other, where they form hydrogen bonds. This bond is behind what makes water properties so unique. Cohesion is a property that allows water molecules to stick to each other. Adhesion properties mean that water molecules also stick to other materials. Because its adhesive properties are stronger than the cohesive forces, the water spreads out as opposed to sticking together in a mass. In its solid form, ice, these hydrogen bonds are what give it the ability to float on its liquid form. Water molecules form a crystalline structure at freezing temperature, which is less dense than its liquid form. Hydrogen bonds also affect the thermal properties of water. This is important in terms of climate because water has a high specific heat index or heat of vaporization threshold, meaning it can take large amounts of heat before its temperature rises considerably. Air pressure affects the boiling point of water. Water boils at 100 degrees Celsius or 212 degrees Fahrenheit, but this is at sea level under normal conditions. The boiling point of water changes relative to the barometric pressure. There are often several minerals dissolved in water. The presence of these minerals is the difference between hard water and soft water. Hard water usually contains calcium and magnesium, but may also contain other metals. It can cause limescale deposits in pipes, water heaters, and toilets. Water is a universal solvent, meaning many substances, such as salt or sugar, dissolve in it. Substances that dissolve in water are hydrophilic. This means that they are as strong or stronger than water's cohesive forces. Substances that naturally repel water, causing droplets to form, are called hydrophobic. Salt and sugar are examples of hydrophilic substances. They dissolve very well in water. Both hydrophilic and hydrophobic materials can have effects that are beneficial in a variety of functions. Substances like these can have significant impacts on how things are manufactured, such as power plants, desalination plants, electronics, materials for transportation, as well as airplanes and even food packaging. Plants are often over 90% water by weight. They contain a higher percentage of water than animals. Just as it does in animals, water regulates the plant's temperature and transports nutrients throughout. Plants use their roots to take in water, and for photosynthesis, they require water to create sugar for food. Pressure from the process of osmosis, the movement of water from the outside to the inside of the plant cells, maintains the structure of the plant's cell walls. Plant cells have a large central vacuole in which they store water. Plants take in water through capillary action. Xylem vessels move the water from the roots to the rest of the plant. After reaching the leaves, the water escapes through small holes called stomata, which open to allow carbon dioxide to enter and oxygen to leave. This also helps the plant cool down. Similar to how people sweat, this process is called transpiration. Water is odorless, nearly colorless, and tasteless. It is in the food and beverages we ingest, and it makes up approximately 2/3 of our bodies, so it is no surprise that we cannot function without it. Water helps regulate our body temperature, brings nutrients to our cells, and flushes out waste. Our lungs are 90% water, our brains are 70%, and our blood more than 80%. Most people sweat out about 2 cups of water per day. During this process, we lose electrolytes, which are minerals like sodium and potassium that help regulate the body and need to be replaced. We can get about 20% of the water we require through food. Humans usually require about 8 cups or 2 liters of water per day through food or drink. Some foods like cucumber, celery, or watermelon are nearly 100% water. Currently, approximately 17% of the world's population, more than 1 billion people, do not have access to clean water. There are several organizations, including UNICEF and WaterAid, working to help disadvantaged communities in Asia and Africa obtain sustainable supplies of drinking water and sanitation facilities. Water shortages happen in the United States, too. Many states have programs to assist the disadvantaged with obtaining enough water and paying their water and sewer bills. Desalination is an important process that removes salt from water. Salt water can be bad to ingest because it results in dehydration. Scientists and engineers are hoping that new desalination technologies will help disadvantaged communities by giving them clean water options. Desalination processes force water under high pressure through a semi-permeable membrane. The membrane allows liquid to pass through, but not solids such as salt. This method of desalination is referred to as reverse osmosis. Desalination only meets a very small percentage of our needs, but scientists are always trying for improvements in energy efficiency. Scientists are excited about the use of graphene in desalination. Graphene is hydrophobic and repels water. Scientists have tested narrow capillaries made from graphene, allowing for rapid permeation. Graphene capillaries that are 1 atom wide are now inexpensive and easy to produce. The process would work by stacking layers of graphene oxide, a derivative of graphene, on top of each other. The resulting multi-layer laminate stacks have a structure similar to nacre, mother of pearl, which makes them mechanically strong. Researchers have discovered that thin membranes made from such laminates were impermeable to all gases and vapors except for water. Even helium, the hardest gas to block off, cannot pass through the membranes, whereas water vapor went through with no resistance. It could be a monumental discovery in terms of desalination capabilities. Freshwater is important to economic development and the environment. Population growth and changes in climate have created an increasing demand for fresh water around the world. Desalination of ocean and brackish water is a possible solution to clean water shortages. Scientists at the Naval Research Laboratory are conducting research into using seawater as fuel. In the next 7 to 10 years, scientists claim that the military will be able to run jets, ships, and other vehicles on a fuel derived from seawater. The process is called a fixed-bed catalysis, where they are able to recover hydrogen and CO2 from seawater. However, it is currently highly energy-intensive, requiring almost twice as much electricity to convert the water into fuel components. Catalysis is a process that combines chemicals, energy, and pressure to accelerate chemical reactions. Currently, the cost of the fuel is $3 to $7 per gallon, but those numbers should get better in the coming years. With a stable and clean electricity source, seawater-based fuel could reduce dependence on oil or other polluting fuel sources. There are many exciting and rewarding careers regarding science and water. For instance, the EPA, or Environmental Protection Agency, has the mission to protect human health and the environment. Therefore, it is their focus to promote excellent water quality while monitoring pollution and threats to our water supplies. Other exciting fields include water conservation, purification, and distribution and infrastructure. Corporations such as Veolia Water, Lockheed Martin, Atlantis Technologies, and Calgon Carbon offer careers that cover a wide variety of water-related issues. Water is essential to life and is one of the most important compounds on Earth. Every day, scientists strive to find ways to increase the size and quality of our water supplies. Through basic understandings of science, we've been able to acknowledge many of the mysteries of water, and in the future, there is plenty of room for scientists to improve the quality and availability of this precious resource. They're not always on our minds, but our lives are powered by batteries. For most of us, not a day will go by that we're not using a battery, whether it's in our cars, our phones, the remote to the television. If you've ever tried to find an extension cord to plug in a vacuum or a hedge trimmer, you might realize the importance of portability. And this is what makes batteries so important. Imagine using your phone or MP3 player while being plugged into the wall. The convenience of batteries has led to the invention of more new technologies, appliances and equipment that operate best with flexibility of range. There are now commercially available automobiles fully powered by batteries, eliminating the need for a transmission and emissions. There are fully functional lawnmowers with sufficient power to cut through thick grass, and there are large-scale batteries that are being built to harness the power generated by renewable energy sources, such as solar and wind. Batteries have been around for over 200 years. The first batteries used chemical solutions and were inconsistent and dangerous. They contained wet cells with liquid electrolytes, which were prone to spillage. Italian physicist Count Alessandro Volta was the first to create a battery in 1799 from metal plates and brine-soaked cardboard or paper. Since then, scientists have built upon Volta's original design to create batteries made from a variety of materials that come in many sizes. A battery is a device containing an electric cell or series of electric cells storing energy that can be converted into electrical power, usually in the form of direct current. This is known as an electrochemical reaction. Batteries store chemical energy and convert it into electrical energy. A typical battery, such as a car battery, is composed of galvanic cells. Each cell contains two separate metal electrodes immersed in an electrolyte containing both positive and negative ions. Batteries are equipped with two terminals. The positive terminal is marked with a plus sign, while the other is marked as negative. In most small consumer batteries, such as the AA, C, or D cell, the terminals are located at opposite ends. On a car battery or a 9-volt, however, the terminals are next to each other on the top of the battery. These terminals are then connected to a load, such as a remote control, a motor, or a radio. Batteries usually have a metal or plastic case. Within the case is a cathode, which connects to the positive terminal, and an anode, which connects to the negative terminal. These components are known as electrodes and are where the chemical reactions occur to create power. Between the cathode and anode is a separator, which prevents the electrodes from touching while allowing electrically charged ions to migrate between the two. The conductive medium that allows the electric charge to flow between the cathode and anode is the electrolyte. Finally, the collector sends the charge to the terminals on the outside of the battery, which powers the load. In the United States, most household batteries, such as the AA, C, or D cell, are alkaline batteries. This type is dependent upon the reaction between zinc and manganese dioxide, and it gets its name because it has an alkaline electrolyte made of potassium hydroxide. The mobile device boom of the past several decades has increased the demand for longer-lasting rechargeable batteries. Lithium is the lightest of all metals, has the greatest electrochemical potential, and provides the largest energy density for its weight. Pure lithium is highly reactive. It reacts vigorously with water to form lithium hydroxide and hydrogen gas. Lithium-ion batteries are now one of the most popular types of rechargeable batteries for portable electronics due to their high energy density, no memory effect, and slow loss of charge when not in use. Handheld electronics mostly use lithium-ion batteries based on lithium cobalt oxide. The battery works because lithium ions move from the negative electrode to the positive electrode during discharge and back when charging. A lithium-ion battery is nearly the same as the alkaline battery in design, but the chemicals are different.
Rechargeable battery cells are manufactured in cylindrical or prismatic cells, as this animation illustrates. First, copper is rolled into a foil that serves as the current collector on the anode side. Aluminum is used on the cathode side. Next, the electrode is deposited onto the current collector foil. The anode is typically made of graphite and the cathode of lithium containing oxides or phosphates. The electrode coating goes through a drying step in which unnecessary solvents are removed and the slurry-based coating is solidified. After drying, the two electrodes come together in a sandwich structure with two separators, shown in green, positioned in between. This flexible layer structure then goes through a winding process and forms what is called a jelly roll. For prismatic cells, these structures are cut and layered, flatly rolled, or Z-folded. Next, the jelly roll is packaged into a cylindrical container that resembles an oversized AA battery. Here you can see the internal structure consisting of the two current collectors with electrode and the two separators for avoiding a short circuit. Before sealing and crimping the container, the battery is filled with liquid electrolyte. It is critical that the electrolyte wets the separator and fills all pores, leaving no or minimal voids in the separator foam. 8 to 12 cells are packaged in a module. Then 8 to 12 modules are packaged with a battery management and cooling system. Such a battery pack can then be used in plug-in hybrid and all-electric vehicles. The same or very similar battery packs can be used for stationary storage to enable intermittent renewable energy sources such as wind and solar.
The volt, or voltage, is the unit of measurement for the work done by a machine powered by an electrical source, similar to how horsepower is a unit of measurement for the strength of a combustion engine. A battery's capacity is measured in amp hours, which is similar to the amount of gasoline in a car's tank. Higher amp hours result in longer battery run times. While many standard battery-powered lawnmowers utilize a 40-volt battery, Ego is a company that has revolutionized the world of outdoor power equipment with the industry's first 56-volt battery. This increase in power makes yard work easier with improved performance and durability. Now, to help put things into perspective, smartphones require 5 volts. A vacuum cleaner is often 15 volts. Circular saws work at 18 volts. Electric drills need 20 volts. Most battery-powered outdoor maintenance equipment, 40 volts. The Ego Power Plus lawnmower is 56 volts. How were Ego engineers able to design this 56-volt battery system to work efficiently? Well, more volts means more power, which results in more heat. Heat is bad for batteries. The Ego Power Plus lithium-ion battery features breakthrough technology, a unique arc shape which allows it to dissipate heat more effectively. Ego's batteries also use a phase change technology to draw and dissipate heat from individual battery cells. These two features make it possible for Ego to provide the highest voltage lithium-ion battery platform that can operate under hot conditions. Careers in the fields relating to batteries can be exciting and rewarding. Just to name a few, they are engineer, specifically electrical engineer, materials scientist, chemist, physicist, and nanotechnology researcher. While we may often take batteries for granted, they are all around us, powering our phones, computers, flashlights, cars, and many other portable devices. Batteries are a modern convenience that we've come to depend on more and more in recent years. In fields such as health and renewable energy storage, we'll see exciting new advances. With additional research and innovations, batteries will become smaller, more dependable, and will last longer in the future. They are a modern convenience that will help improve our quality of life for years to come. Mining of metal and stone dates back to prehistoric times. These processes are required to obtain materials that cannot be grown agriculturally or created artificially in a laboratory. Modern mining often focuses on ores, including metals, coal, oil, shale, gemstones, limestone, and many more. Many nations have adopted strict regulations to moderate negative effects and to ensure a minimal impact on the environment. The most abundant metal in the Earth's crust is aluminum. Aluminum is naturally found in the form of bauxite, an ore containing aluminum oxide, or alumina. Alcoa mines bauxite from reserves in Australia, Brazil, Suriname, Jamaica, and other parts of the world, processing most of it into alumina. It is extracted from the bauxite through a process called refining. Bauxite is found in deposits around the world, but mostly in the tropics. The formation is sped up by the weathering of aluminous rock. The process to mine bauxite from the ground is destructive to the plants, animals, and landscape of the area. To address these concerns, companies like Alcoa develop a rehabilitation plan before mining even begins. The site will undergo transformations, but Alcoa strives to ensure future sustainability of the land. In most cases, they attempt to return the land to its original condition: forests, swamps, farmland, and grassland. In Western Australia, they set an industry benchmark with mine rehabilitation. Mining occurs in the Jarrah Forest, which is renowned for its diverse flora. The goal is to restore 100% of the species richness to the rehabilitated areas 15 to 18 months after rehabilitation is complete. Alcoa employs a nursery to provide seeds and plants to meet their needs. At another mine in the heart of the Brazilian Amazon, rehabilitation efforts occur in parallel with the mining process. They minimize vegetation removal and maintain genetic material, usually seeds, from threatened species and relocate certain animals to preserve areas. In some cases, such as in Jamaica, rehabilitation is accomplished to support other productive land use, for instance, converting it to farmland. Since most metals are present in ores as oxides or sulfides, the metal needs to be reduced to its metallic form. This can be accomplished through chemical means such as smelting or through electrolyte reduction processes. Inside large carbon-lined horizontal furnaces called pots, alumina is dissolved in a molten sodium aluminum fluoride solution called cryolite. Sending a powerful electric current through the cryolite solution in the smelting pot causes molten aluminum metal to separate from the alumina, falling to the bottom of the pot where it is siphoned out. The metal is then cast into ingots of varying shapes and sizes that are later fabricated into aluminum products. Aluminum smelting requires significant amounts of energy and releases greenhouse gases, but companies are attempting to reduce the negative impacts. More than 2/3 of the energy used globally at Alcoa smelting facilities now comes from renewable sources. In Canada and Iceland, they're powered solely by hydroelectric power. To meet longer-term energy reduction goals, they're researching the availability and potential of harnessing geothermal power. Due to the energy required, aluminum smelting results in the emission of greenhouse gases, primarily carbon dioxide. For over 2 decades, Alcoa has reduced these emissions and achieved long-term reduction goals ahead of schedule. The current goal is to reduce carbon dioxide intensity by 30% by 2020 and by 35% by 2030 from 2005 levels. Spent pot lining, which is generated when the carbon and refractory lining of smelting pots reaches the end of its serviceable life, is also a significant byproduct. Scientists are researching the opportunity to transform spent pot lining into fuels and other raw materials for other industries, such as cement manufacturing, mineral wool production, and brick fabrication. Refining is a process that is required to purify a substance. The aluminum refining process is the intermediary step in converting bauxite into aluminum. In this process, they grind the ore while mixing it with lime and caustic soda. This mixture is pumped into high-pressure containers and heated. The caustic soda dissolves the aluminum oxide, which precipitates from the saturated solution and is washed and heated to drive off water. What remains is white powder called alumina. It's used in chemicals or smelted into aluminum. A significant byproduct of the refining process is bauxite residue, which is mainly sand and mud, with some residual caustic soda and other components. To protect the local environment, bauxite residue must be managed appropriately. Most of the 120 million tons of annual residue must be stored. The goal is for it to be stored in secure earthen impoundments. Alcoa scientists are researching ways to use bauxite residue as a source material in a variety of applications. They develop methods to reduce the environmental footprint of residue storage and chemically render the material so it's more suitable for reuse or long-term management. In Australia, they use a process that converts bauxite residue sand to a product called red sand that can be used as a general fill material, construction backfill, or road-based construction material. One of the world's most sustainable food and beverage containers is the aluminum can. In less than 60 days, they can be recycled and back on the store shelf. In addition, recycling aluminum uses only 5% of the energy required to make new aluminum ingot. Alcoa operates the largest can reclamation facility in the world. This facility alone remelts enough used beverage containers to make billions of new aluminum cans each year. Making new can sheet for beverage containers begins with remelting the material and casting it into ingots that can be nearly 8 meters long and weigh 20 metric tons. Each ingot is sent through a scalper where its surface is shaved for optimization. Then it goes through a series of rolling mills where it's transformed into a thin coil. These thin coils are run through a cold mill at speeds up to 96 kilometers per hour to reduce the gauge of the material to only 26/100ths of a millimeter thick. In 60 seconds, this plant can produce an aluminum sheet that can make up to 145,000 cans. The final step is trimming the coils on the high-speed slitting equipment and packaging and shipping them to beverage plants around the world. But Alcoa doesn't only deal in aluminum. They manufacture a variety of products that are made of several alloys and metals such as titanium, nickel, and cobalt. To help drive sustainability into numerous downstream industries, Alcoa is the world leader in production of blades and vanes made of advanced superalloys for the high-temperature environments in jet engines and industrial gas turbines. Alcoa uses innovative technologies to design blades and vanes that are capable of operating under higher temperatures, improving overall energy efficiency, reducing noise, emissions, and the overall carbon footprint. The Alcoa Howmet Casting Operations is a leading producer of complex industrial and aerospace fasteners, made from aluminum, corrosion-resistant steels, titanium, superalloys, and more. These fasteners have helped to increase aircraft structural integrity, and in fact, every Airbus A380, the world's largest passenger plane, has over 1 million of these fasteners. Aluminum is an ideal material for transportation applications. It's strong yet lightweight, helping to reduce the overall mass of an aircraft or vehicle to improve fuel economy and reduce carbon emissions. Aluminum is infinitely recyclable, giving manufacturers a sustainable end-of-life solution for their products. For the next generation of single-aisle airplanes, new aluminum alloys and technologies will lower the weight of the plane by up to 10%. The hub of Alcoa's aerospace structures business in Davenport, Iowa, has produced metals for every space vehicle in America's program and all major aircraft, including Air Force One. At the plate mill, they can precisely trim and taper airplane wings up to 37 meters long using giant computerized milling machines. A variety of careers in the industry offer exciting and challenging futures. Lightweight materials technology is a field that is advancing quickly at the demands of many industries: automotive and commercial transportation, air and space travel, and industrial and consumer electronics. Metals are an important part of our society, and thanks to advances in science, we've become efficient at locating and refining metals to fit our ever-growing needs. Aluminum is the most abundant metallic element on Earth and the third most abundant of all elements after oxygen and silicon. We found it to be extremely useful due to its relatively soft, durable, and lightweight properties. Thanks to science, this remarkable metal has proved to be vital to many industries, and the ability to recycle it allows us to take advantage of a sustainable cycle for years to come. The process that powers the sun and the stars is called fusion. It is energy that makes all life on Earth possible. This fusion energy is produced in the sun by fusing the lightest atoms, such as hydrogen, together at extremely high pressures and temperatures. At these temperatures, gas becomes plasma, the fourth state of matter. Solid, liquid, and gas being the other three. Telescopes such as the VLA and ALMA and space-based observatories such as NASA's Hubble and Kepler have captured stellar visuals of the Sun and galaxies millions of light years away. However, as impressive as these images are, scientists wanted to create the events that might have led to the creation of these planets and stars to strengthen their understanding of the cosmos. In addition, researchers in plasma physics are trying to build fusion reactors of their own to create fusion energy as a safe, economical, and environmentally attractive source for the world's long-term energy requirements. On opposite ends of the United States, there are facilities working on fusion research: the National Ignition Facility in California and the Princeton Plasma Physics Laboratory in New Jersey. But first, what is fusion? Fusion is what happens when the nuclei of light atoms overcome the electrical resistance that keeps them apart and get close enough to activate the strong nuclear force that holds them together, or fuse. When fused, they form a bigger nucleus. Two elements combine to create a different element at the level of the nucleus. Making elements fuse requires an enormous amount of heat and pressure, like that found in the cores of the Sun and stars. Before it formed some 5 billion years ago, the Sun was a cloud of gas, mostly made up of hydrogen and helium. Eventually, the cloud became so massive that gravity caused it to collapse in on itself, and it formed a star. Numerous collisions in the core of the Sun freed electrons from ions, forming a plasma state. Fusion began in the Sun when collisions between ions became so frequent that the ions got close enough to fuse together. Thus, the Sun is a natural fusion reactor.
The Princeton Plasma Physics Lab is a Department of Energy national laboratory. We are trying to confine a plasma 10 times hotter than the core of the Sun. And at that temperature, we'll generate fusion energy that we will then convert to electricity. We're trying to produce a star here on Earth.
So a plasma is a hot gas. This beautiful, beautiful, distinct state of matter can be manipulated by, let's say, a magnetic field. And there are examples all around us. It's the Sun and the stars and 99% of the visible universe.
So fusion energy is the way the Sun works. It takes very light elements and fuses them together to make heavier elements. That releases energy. It's the opposite of fission, where you take very heavy atoms like uranium and split them apart.
Scientists at the Princeton Plasma Physics Laboratory, or the PPPL, involved in the National Spherical Torus Experiment, or NSTX, use a spherically shaped magnetic device to study the effects of fusion. A tokamak is a device that uses a magnetic field to confine plasma in the shape of a torus. A stable plasma equilibrium requires magnetic field lines that move around the torus in a helical shape. NSTX uses deuterium, one of two stable isotopes of hydrogen, to produce a plasma that is shaped like a sphere with a hole through its center. The unique plasma configuration has the ability to confine a higher plasma pressure for a given magnetic field strength. Magnetic fields confine the hot plasma since solid materials cannot withstand the extremely high temperature of the plasma. The tokamak uses a combination of external magnets and a current driven in the plasma to create a stable confinement system. Because the amount of fusion power produced is proportional to the square of the plasma pressure, scientists propose that the use of spherically shaped plasmas might allow the development of smaller, more economical fusion reactors. On the West Coast, the National Ignition Facility, or the NIF, uses 192 laser beams that converge on a target to produce temperatures, pressures, and densities that are similar to those in the cores of stars, supernovae, and giant planets. These experiments are particularly relevant to astrophysics, the branch of astronomy focused on understanding the physics of the universe. The physics of stars and other astrophysical phenomena, such as supernovae, black holes, and planetary interiors, are not well understood. By creating tiny parcels of plasmas under extreme conditions, scientists at the National Ignition Facility can better understand the physical processes that they could only previously observe from great distances. In essence, the NIF allows scientists to visit inaccessible parts of the universe. Experiments at the NIF are transforming astronomy from an observational to an experimental science. What is ignition? NIF ignition experiments use a very small container called a hohlraum that holds a plastic capsule filled with deuterium and tritium, which acts as fuel. Deuterium is extracted from seawater, and tritium is produced by the transmutation of lithium, a common element in the Earth's crust and oceans. To create fusion reactions, scientists simultaneously direct 192 lasers into the small hohlraum with a peak power of 500 trillion watts, roughly the energy the United States consumes every 6 minutes. This heats up a 1 centimeter gold cylinder to millions of degrees, which produces X-rays that are directed at a point the size of a BB pellet. The X-rays blast the shell, creating an implosion that shrinks the gas inside the pellet to 1/35 of its size, compressing the deuterium and tritium to incredible densities. At the center of this hydrogen plasma, in an area smaller than the width of a human hair, the atoms fuse. This gives off energy, which should in theory set off a chain reaction that ignites the rest of the hydrogen and creates a self-sustaining ball of fusion. The National Ignition Facility made history on July 5, 2012, when its 192 beams delivered more than 500 trillion watts of peak power and nearly 2 megajoules of ultraviolet laser light to its target. That's 1,000 times more power than the United States uses at any instant in time, and nearly 100 times more than any other laser facility regularly produces. But they have a long way to go in making it a reliable, constant source of energy.
I was attracted to plasma physics because I wanted to help turn fusion energy into a reality. I liked the idea of being part of a larger mission, with the whole global community working together to solve this grand challenge. I've had a wonderful experience here at PPPL. I've had the freedom to explore the problems that really interested me. And not only that, but I've been able to travel all over the world and meet with other scientists and collaborate with them in solving these problems.
While it can be extremely difficult to achieve, a career in these fields can be challenging and highly rewarding. From engineer to nuclear physicist, you could help shape the future of the world's energy production. A fusion power plant would not emit greenhouse gases and would not require disposal of radioactive waste. A fusion power plant could run off an almost unlimited fuel supply and would present no danger of a meltdown. Since nuclear fusion offers the potential for nearly unlimited safe and environmentally friendly energy, the U.S. Department of Energy has made fusion a focal point in the nation's long-term energy plans, with investments into magnetic fusion energy and support of the NIF. And hopefully, fusion will soon play a role in our ever-growing energy demands.